We have a new lesson for you today on how to create the drawing file for the right angle brace drawing. So this is also going to serve as a bit of a review from what we have learned previously when we did the same thing for the die punch drawing. So I'm going to be going into content in the Introduction to Autodesk Inventor Solid Modeling module, selecting this image. And we're going to be scrolling down and taking a look at the right angle brace. Now, the units are fractional, which is an adjustment we're going to have to make in our drawing file, which is very simple to do. And I want to take note of these lines with a dash that appears now and again that kind of lines up the center of this hole to this hole. So this is called a center line, and this is something we talked about in the die punch, and it is a mechanical drafting standard that we're going to have to add to our drawing. So a center line is important because it represents symmetrical features in a drawing. It helps to line features up. It basically tells a story here that this hole and this hole are directly in line with each other from center to center. Same with these two as well. And anything that is completely round in a drawing requires a center line. So basically anything that is cylindrical, right? These holes are cylindrical. They go right through the right angle brace. They need to be identified on the drawing file. We're also going to be taking a look at dimensioning, how to place dimensions on this drawing proper as well. So when you perform this work on your computer, again, make sure you have this screen open on your iPad next to your monitor while you're working, so you can easily just turn your head back and forth and use it as a reference. Again, don't toggle back between screens. It's something that I don't do, and I really encourage you to do the same thing. So Inventor is already running. We're going to open up the right angle brace. And this is it right here. So this is the one that I had drawn earlier in a previous lesson. So before we can start any drawing file, we have to have the .ipt file open, which is the 3D solid model file. Alright, so here it is in perfect isometric view. So we're going to be creating a front view looking in this direction, a top view, and the right side view from this orientation. So we're going to put it back into an ISO view. So to do this, this is a bit of a review from before. We're going to File, we're going to New, and we are going to make sure we're in English. So watch where you are under templates, right? So this is fractional. So this is English units. So English, we're going to select ANSI inch .idw. So .idw stands for drawing file. .ipt stands for part file. So we need to understand these file types and extensions. We're going to hit create and allow that to load up. Okay, so as before, drawing files will default to a D-size sheet. Now, the D-size sheet is too big for this, but the A-size sheet, which we used before for the die punch, that's going to be too small. So we're going to go to Drawing Resources, we're going to click Sheet Formats, and we're going to use the B-size sheet. So this is really meant for 2 views, even though we're going to be doing 3 views this time, but we should be able to squeeze them in. I think we can get them to fit. So we're going to double click it, and then we're going to hit OK, and it's going to change this to a B-size sheet. Now, So that automatically brings in the 2 views of the 3 you need when you do that. So a little review, front view controls the dependent view. So I can't move this up or down with the right side view, but I can with the front. So I want to just move these like this, and I may move them again until I'm satisfied with their position. But we're trying to get the views typically centered by eye as best we can inside the sheet border. Now, one thing I wish they wouldn't do is have the title block so high in rectangular shape. I wish they would break this up a little smaller so we can span it all to one side. But it's something that I can work on at some point when I have the time, is I'm going to try to customize these title blocks and load them into Inventor. But again, it's one of those things, and we're, things are very busy right now. So moving on, we're going to create the top view. So on the front view, we can right click, left click create view, go to projected view and left click. This is going to create the last view we need. So we're creating an orthographic projection, something we'll talk more about later. So we're going to left click, right click, and then left click create. So these are the 3 basic views. Because this is not a cylindrical part, we need more information to be able to detail this part in a drawing so someone in the shop can actually manufacture it with machine tools. And that is the point of this course, right? This course is a focus on technical drawings. From drafting and design, we're looking at mechanical drawings and designs first, and then you're going to have a chance to look at architectural later in the semester, and you're also going to be doing architectural design. So just in case you were wondering, we do mechanical drawings first in the course. Okay, so now that we have the views in place, we need to create what's called center lines. So this is the next step. So we need to actually create center lines here, which is a drafting standard. So we're going to click from place views to annotate, and we're going to select the center mark here. This is going to create center lines all at once for these round holes. So we're going to hit center mark, we're going to select the circle here and here. This automatically creates the center line, and these center lines need to extend beyond the feature they're attached to. Now this is a drafting standard. Inventor is smart software, so it extends them for you automatically, which is great. We're going to do the same thing here and here. And that is it for the holes. Now, so we're going to right click, left click, OK. We're also going to create center lines here and here and here, because these features are holes as well. Now these holes are hidden from your view, so that's why they show up dashed. So if I click back into the part file here and I click the top view, we'll orient it as it's seen in the drawing file. Again, we clearly see through these holes, but there are holes here and here on this top surface that we can't see in real life, right? But a drawing file will reveal things that we typically can't see by our naked eye. We have to show them with dashed lines that are called hidden detail lines. And those are round, so they require a center line. So if I go back to ISO view, right, you can clearly see those circles and how they pass through the back of the part. So we're going to use, this time we'll use the center line bisector. So we'll select it, we'll select this hidden line and this hidden line, and it will automatically add the center line. So we'll click here and here. Those ones are done. We're going to click here and here. Same thing in this position, because there's 2 holes in line with one another here. So we just need one center line here and here, and then we also have the holes as seen from the right side view. Like this. All right. Now, one thing that we talked about is that these holes are in line with one another. So we need to adjust the center line to travel from the hidden view to the visible object view, right? So this is going to help tell a story in our drawing, right? The center line will communicate to the person in the shop, okay, so when I drill these holes, or however I add them, they are in line. So I can just take the center line, and when these green snaps appear, I can select this one at the top and pull it up and drop it right before it gets to that center mark, right? And that's gonna, as I stretch that center line up, it automatically creates that dash that you see in the image file on your iPad. So we're gonna do that again. We're just gonna stop. We don't wanna bring it right up to the center mark line. We wanna just eyeball it to stop a little bit before. We wanna maintain that break. So the front view doesn't require it, but the top view does. So don't grab it from the center mark, but grab it from the center line. If you grab it from the center mark, it'll just continue a line solid without that dash every so often. So watch what happens to this this little dash when I drag it. Right? It creates them as I drag it. So I'm going to stop around here and then do the same thing. This is the last time. Right here. Okay, so we've got our center lines identified. And at this point, it's a good idea to save your work in case the computer crashes or something bad happens. So I'm going to go to File, hit Save As. Here's the die punch that I did earlier, and I have a folder here called Basic Solid Modeling Lessons. I'm just going to keep the name right angle brace, and I'm going to hit Save. This borrows the name given to the part file. And remember, these files need to be kept together. You can't take this drawing file and put it somewhere else on your computer and expect to be able to open it up and have it appear in the border, right? You have to keep your part file with your drawing file. So always keep those files together in a folder. So we're going to hit Save. Okay, we've got our work saved. We're also going to create the isometric view in the top right-hand corner. This is something that I showed you in the die punch as well. So we're going to go to the front view, right-click, left-click, create view, hit projected view, and the right-angle brace isometric view can be dropped right in the top-hand corner here. Right-click, left-click, create. Now, that's scale. This is scale 1:1, and so is this. But it appears so large. It just should not try to overpower our two-dimensional orthographic views. So we're going to double-click this one, and we're going to scale it down again. So we're going to scale this to 3/4, 3/4. Hit OK. It's going to scale it down, and now that looks better. This is just a bonus view. It just sits up in the top right-hand corner, gives the person in the shop a bonus view of what it looks like in real life, three-dimensional isometric. No hidden details are turned on for this either usually. So if I double-click this, I can hit Hidden Line and OK, and it reveals the hidden features that normally can't be seen by your eye like we're seeing in the 2D views. But again, we don't need to leave those on. We can double-click, turn that off. Oh, it's giving me trouble. Okay, hidden lines removed. This is the one I need to pick. So it's not a case of clicking it off. You have to click to remove. Hit OK. All right. So now we can drag this a little closer to the top right-hand corner, kind of tuck it away up there where it's not going to get in our way. Just like that. All right, we also need to fill the title block in. So here's another review. We're going to go to File, iProperties and summary. So I'm changing, so under author, you need to make sure your caps lock is on. Type your first initial, period, space, and your last name. I drew this one, so I'm adding my name. The company is our school. Our title is the right angle brace. And we can also click over to project. Revision number is going to be 0 because this is an original release of the drawing. It's unrevised. If we made revisions to this as we go, we would rev them up to 1, 2, and so forth. This is original, so we're leaving it at 0. Part number. So this can be changed to 3M1-02, last 3 digits of our course code, and it's our second drawing. Under status, we can also add a person's name from the class that would check your work for you. So I'm going to add Mr. Valance because he checks all my work for me. Good guy. And I'm going to activate the date for that as well. And I'm going to hit apply and close. And let's inspect this. Okay, so we got who drew it, checked, title, school name. This is automatic, B-size sheet, 1-to-1 scale, and a drawing number, Rev 0. So that is perfect for us. All right, so we're going to start by running some dimensions. Now, I'm going to be talking about running dimensions properly. I'm not going to get into a giant lesson about that, although I will talk about that another time. We're just trying to get our experience off the ground here. So I'm going to start by basically I'm going to run all the dimensions that you see here, or most of them. There's a bit of over dimensioning happening here. We don't need all these dimensions, but we do need most of them. And we're going to be placing them in the view that makes the most sense as we go. So I'm going to be doing this very close to this, but I'm going to be making some professional changes because there's some, mistakes on here. This is meant to get the critical thinking flowing. So to begin, I'm going to start with the angular dimension. So I'm going to annotate tab, clicking dimension, and I need to represent the angle, which is 30 degrees. So I can click this angular line, this horizontal line, and I can pull this dimension. And I'm going to want to pull it until about here. As soon as if you zoom in on this, I want the 30 degrees to go inside. So I can pull it until the numeric value goes inside the arrows. And I'm waiting to drop it till it breaks. So when you see those lines get dotted, that gives you an indication of where you can drop the dimension. So it breaks for you. So it's giving you an indication as to where you can drop the dimension. So I'm going to drop it here, left click, and then just hit OK. And there's my angular dimension done. Next up, we are going to add the 1 3/8 dimension. So we need to know how much it is, how long this horizontal line is. So we're going to go dimension. We just select a line, and we're going to zoom in on this, and we're going to want to break it right here, right? So we're watching for that dotted section to appear right there. So this is how I know where to drop my dimension. If I do this, if I drop it here, it's too close. If I drop it here, it's too far away. Right? Dimensions have to look good. So we're going to drop it right where it breaks. Hit OK. Now you're going to notice something here. This does not look like a fraction. Right? I'm breaking my rules here and I'm clicking back and forth. All these dimensions are shown as fractional. So this is defaulting to decimal form. So we need to change this. So we're going to be changing this once and applying it to the rest of the dimensions. So we can right click, left click OK. That's going to escape us or end the dimension command. Then we're going to go back to this dimension and right click it. And we're going to scroll to edit dimension style. And the format is currently set to decimal. So we're going to be changing this to fraction. And I think diagonal looks the best. So let's pick fraction diagonal. And we're going to be changing the precision to 1/16. Now this is for rounding fractions, right? We want this to be more precise than 1/4 inch. 1/16 is more precise. We're going to click over from units to text, and we're going to add the unit suffix, which is shift. It basically adds the quotation mark here in suffix. So once we've done that, we're going to hit save and close. And that updates that for us. So that looks pretty good. It's got the fractions, got the suffix. Now you're going to notice something here. Okay, I don't want this on my 30 degrees. So I'm going to have to fix that later. But I'm going to leave that till last. I'm going to come back and take care of that before I finish this lesson. So I'm going to continue on. I've got this dimension placed, which is a part of my dimensioning scheme here. I want this dimension. This is a great spot for this dimension, except I'm showing it in orientation with the front view, not projected with the top view like we see it here. Moving on, we're going to show an overall length for this. So I could place this dimension on the top view or the front view. I'll put it on the front view. So I'll go dimension. We're going to pick this line and this line here. And we're going to zoom in and wait for this to break, right? So that's kind of far away. I would drop it. It breaks right here. So the first dimension is generally a little further away from the part. And then every stack after the fact and subsequent stack appears more often or with less of a gap. So we can break that right here and hit OK. All right, so we've got that one done. We also need to show the height of this, which is 2 3/4. So I'm probably going to come back and show that dimension in a little bit. I'm going to see what else I can do because I need to think about how I'm going to place these. So the distance between here and here is 9/16. So let's do that one. We're going to click this horizontal line, the center line, and we're going to drop that right there at that first break point. Notice when you run a dimension, this is called the dimension extension line, which comes off of the part that the arrows point to, right? The extension line tells us that this dimension starts at this feature of the drawing and runs to the center line or center mark of this hole. So there has to be a break. And this happens by itself if you snap the end of the center line. If you snap in the middle, this is going to want to travel all the way to the center mark and won't be proper. So make sure that when you're doing this, you're selecting this line and you're selecting the end of the center line. So I'm going to repeat that again up top. We're going to show the 1 1/8. So we're going to select the end of the center line, the end of this center line. It's going to pull the dimension off. And it's going to want to line up perfect with that 9/16 because we want those arrowheads to line up. We don't want the dimension sitting a little bit more or a little bit less. We want it to drop right in line with that 9/16. So we're going to left click, hit OK. And we got those arrowheads lined up perfectly. Now, there's also another 9/16 that can run here. But I'm not going to add that dimension because that's going to be considered over dimensioning. We don't need the third dimension. And someone might argue, well, how do you know? Well, how does the person in the shop know what size this is from here to here? Well, it's more advantageous to have an overall dimension when we're creating these drawings. So we're actually going to leave that. And we're going to create an overall dimension for this instead. So we're going to create a dimension from here to here, 2 1/4. We're going to drop it where it breaks right there. All right. So we know what the complete width of this is. So if you were to run a dimension like this from center line to this line and drop it here, this is called over dimensioning. Because basically if I add these three numbers up, I'm getting 2 1/4. Why do I need to show all three plus the overall? So in drafting and designing a mechanical drawing, you typically omit one dimension out of a chain. So I need to get rid of one of these. I could get rid of this one or this one. So I'm choosing to get rid of this one. So what I need to do is right click, left click OK, select this dimension, and hit the delete key, like that. Okay, so moving on. We need to know the thickness of the right angle brace throughout. Now this thickness here is the same as the thickness from here to here and here to here. It's being shown as 5/8. Now I don't need to show that dimension twice. I only need to show this dimension once. You only show one dimension one time on one of the views. We don't continue to go around and place the dimension over and over. We're trying to do this with the least amount of dimensions showing as possible to keep the clutter down. So it's best to show a dimension where there's a profile evidence, right? Because this is a flat 2D view of just surfaces, looking at this at the top and the right. The front view has the best profile. It actually shows the profile shape of the right angle brace. So this is the view that I want to add that on. So what I can do is I can show it here or here. It doesn't really matter. So I'm going to show it here, I believe. So I'm going to click from here to here, and I'm going to let it break right there. And then what I want to do is I want to add a little suffix on this. I want to call this tip. So this stands for typical. So when anyone on a drawing sees that word or that short form, it means they're going to know that features like this that are obviously identical are the same throughout. So that means the person in the shop knows that yes, from here to here is 5/8, and from here to here is 5/8 as well. So we're just going to pull that out a bit more because that text was now crowding the part, right? We want to keep a little bit of distance from our first dimension, right? And then the second one can be a little closer and then equally like that as we go. So we've taken care of that. We also need to know the position of the hole from the center mark to the edge of the part here. And that's being shown as 11/16. So we can run a dimension from here to here and then pull it off 11/16. Hit OK. We're maintaining that gap between the center mark and the dimension extension line. Now that is the best place to throw that dimension. Now, some of you may try to do something like this. And I'm going to run this dimension, but this is actually going to be incorrect. If I go from here to here and run the dimension like this, it is the same thing, but this one is correct and this one is wrong. And the reason is this is a hidden feature. So this center line here is attached to the hole in a hidden detail. You can never ever run a dimension to a hidden feature in a drawing. So it's a very black and white rule. We never make an exception for it. You're only ever going to dimension to object features. So we're going to take this dimension and we're going to delete it because it's bad. Hold on. Right click, left click, OK. Now we delete it. The same thing goes for this, right? If we wanted to know the distance from here to here, it's 1.25 inches, but this is incorrect. I am not allowed to run a dimension from here to here. Never, never to a broken hidden line. So if I want to show this dimension, I have to do it on another view where it's clearly visible. So I'm going to be doing it on this side, right? I can click here, dimension from here to here. And where it breaks, drop it. Okay, so that is correct because this is being dimensioned fully to a solid line, which is clearly visible to us. We also need to show the location of the holes from here to here. So we're going to be doing this on the outside of this view. So I have an option here. I could run the dimension on this side or this side. I tend to want to keep dimensions from being placed between views when I can. Of course, I ran the 5/8 dimension here. It's between two views, but we can put dimensions between two views. We just try to avoid it unless there's an obvious advantage. So if I run this dimension twice, which I'm only going to keep one of them, to the center line. So I've got it on the left side and I've got it going on the right side. This is called over dimensioning, right? I don't need this twice. But which one should I keep? Well, I'm going to keep the one on the outside of the right side view because there's no advantage to keeping the one here because, again, it can crowd between views unnecessarily. So we're just going to take this one and delete it. So this is all we need. So we know from the center of these holes to the top surface is 1/2 inch. One thing that we can do is we can connect these here. Like that, so we know that these center lines are also in line with one another. So we can just kind of drag it like that. Next up, we also need to know the total height of this part. Right, so I can put that dimension on the front view or the right view. I can't get a perspective of height on the top view. So I'll run both and I'll get rid of one. So let's run this one from here to here. That's where it breaks. It goes dotted, 2 3/4 inches. And let's do it from here to here. Okay, so again, I've got it twice. This is over dimensioning. I don't need this one twice. I'm going to be inclined to drop it from the front view because this extension line crosses over this one and it's cleaner on the right side view. So either one is really correct, but I think this one slightly wins over this one. So we're going to take this one and delete it. All right, so what do we have left? We've got to show the diameter of the holes next. So these holes, we have 7/16 diameter holes, and there's 4 of them. So what we can do is we can dimension that on the top view or the right side view. So it really doesn't matter. You could do either or. If I did this, I already have a lot of dimensions on this top view. I may decide to run it on this view. So if I go dimension, select this hole, and pull the dimension up like this, we want it to be generally in line with, we want this 7/16 to kind of line up by eye as best we can with this 1/2 inch value here. And we want it to come up about the same kind of distance that you see running from this way horizontally. So we're going to drop it like somewhere around here. And then we're also going to add tip, because that way we can avoid dimensioning the hole 3 more times. Right? So again, typical means features that are obviously the same or just dimensioned 1 time. So this is a 7/16 diameter hole, typical in 4 locations. Okay, so we're taking a look at this. I'm just taking a quick view at my iPad to see if I've forgotten anything anywhere. And it looks like I've got everything. So I think we're going to call the dimensioning on this drawing done. Right, now yours may end up looking slightly different than mine, which is okay, but there should be, again, there would be very minor differences in placement. There should not be major differences, because I basically followed what's called the rules of dimensioning and orthographic drawing. I'm going to throw the note into the hub for you, and I'm also going to post it with this video so you can refer to it and then refer to the verbal lesson I've discussed here as well. So I think we're going to end the video here for today, because we're going to call this complete. Oh, one thing I forgot to do, I said I was going to get rid of that little suffix there on 30 degrees. So what we're going to have to do is, because I took the general dimension feature, like the one that it defaults to, and I changed it to fractions, what we can do is we can just select this dimension and come up to by standard, and we can select default. We can hit default fraction, and that's going to take that away. Because there is a fractional style. I chose not to use it, but by just moving it to that other style, it doesn't have the suffix programmed, it automatically eliminates it. So that's just one quick way to kind of fix that up. We'll talk more about dimensioning setup in the next lesson, but okay, now we're going to end this video. So make sure you hit save. And also, save a copy as a PDF. And this is for when we submit the drawings to the assignment folder. So we're going to go up to File, we're going to go to Save As, and go to Save Copy As. And we're also going to select PDF from the list. I already have the die punch one in there. Then just hit Save. So basically you're going to have 3 files. You're going to have the .ipt file, the .idw file, and the .pdf file. That you'll be submitting 3 files for each drawing when it's time to hand them in. Okay, so I want you to take time today, create the drawing file for this part as you've seen in this lesson, and then tomorrow we'll talk about the control bracket, which will be a little bit more work, but very, very similar to this drawing. So until then, take care, good luck, and talk to you soon.